All right, good morning. That was my nice mic check. It sounds loud to me. Can you all hear me? All right, fabulous. Are you all caffeinated? Yes, good, awesome. That's even better. My name is Laura. If you like, there are screens each side. You can find me on the Twitters as lady_nerd. I mention this because the underscore is important. The real lady nerd does not understand microservices or security, or like people who find me after a conference. So please, find the right one. All right, okay. So this talk is being recorded, so please excuse the slide. This is for the people who are going to watch videos at home. We are in a fast-paced industry, really, really fast-paced. So this is all relevant for today. All of the examples are pulled from the last couple of months, some of it from the last couple of days. But if you're watching this at home, please make sure you're watching the latest advice for whatever field you're in, because seriously, there is some scary stuff out there. Okay, so who the hell am I, and why am I on a stage here? You can tell by the accent I'm not from round here. I live in New Zealand. I'm from the UK originally, and I run a small security firm called SafeStack. I'm not here to sell to you, which is a beautiful thing, because I live thousands of miles on the other side of the planet. So what do I do? Well, I've spent the last 10 years doing bad things to good people's code, to good people in general, lying, cheating, and stealing, and doing a bit of software development on the side. This is my window in my office. It's my Kanban board. We spend 50% of our time doing software development and building things, and 50% of our time helping very fast-moving companies do security. And that means doing security in a way that doesn't get in the way of doing awesome things, because please raise your hand if you think security is the cool, fun part of your job. Just me, right? Good. All right. So what are we going to do today? Well, we're going to look at some fundamentals. Obviously, we've got to start at the same place, and I'm not going to make assumptions about where you're all at. We're not all the people who wrote the book on a subject. We don't all get to use unicorn technologies, and we don't all go cloud first all of the time. I know this because I work with people just like you. We're going to talk about prevention and how we prevent some of the attacks that are going to happen against your microservices, your microservice architectures. And then we're going to talk about detection, because actually prevention is an impossible puzzle. You're never going to be 100% secure. We may as well give that up just right now. If you came thinking, I will be safe at the end of this, nope, sorry, you're screwed. But we're going to talk about how we know that we're in trouble, because that's just as important. So let's start at the beginning. This is how we used to build applications. I don't like putting code slides up very often because, well, most of you spend time looking at my syntax, and I'm what they call an ops coder, which means that I've written some of the dirtiest C++ you'll ever see in your life, and I'm proud of it. I write Python day to day. You're just going to judge me by language choice. So this is a monolith. It was a big piece of naturally evolving source code, which basically meant we gave some interns a project to write once. They wrote a really good little project. We put it live on the internet, and 15 years later, we inherited it. And somehow that is still live and in production. We've now split that into lots of little bits and pieces, each with its own age and story, sometimes each with its own technology. That's where we are right now. Why is this important for a fundamental? Because what we're talking about is we've changed our attack surface. We've changed our architecture. We should know the basics of microservices by now. You've literally got the person who wrote the book in the room running this kind of track today, so I don't need to go into this in depth. But we know the benefits of that are there. For someone like me, however, someone who has lived in the dark places on the internet, has spent a lot of time breaking things, it changes the way we have to approach security a little. You'll have to excuse the voice. I've flown in from New Zealand and somehow caught airplane plague. Okay, right, so what do we care about in security? Before we get into the prevention and the detection, all of the practical stuff you want to get on with, let's get a couple of foundations straight. There are three things I care about as a security person. I care about confidentiality. So if you trust me with your information, and you only trust me to give it to one person in the entire world, then that is my duty of care. That's what I have to do. How many of you work for an organization that stores data for other people? Good, awesome. Most of you in software jobs then. That's good. It's what we do day in, day out. We are secret keepers for all sorts of people, whether that's card information or personal information, health information. It doesn't matter what we're storing. You could be writing Tinder for French poodles. It doesn't matter. You're storing something for someone else. Integrity. If we start with our data in form A, we want it to be form A at the end, or at least we need to know what form it's going to be in. And availability. Let's not forget. A lot of people say, well, a secure system, just turn it off and wrap it in concrete and put it at the bottom of the ocean. That's your secure system. It's just not true. Secure systems are available systems. They're systems you can actually get to and do the job you want to do. Security people, we're not actually the main attraction here. We are like sidecast. We are here to make sure what you do is amazing and people can use it, because if they're not using it, we don't get paid. And I quite like being paid. So, the last bit of our foundation is the types of things we're going to care about in this session. So, if any of you have done threat modeling before, you'll notice this is a set of stride threats that we look at. It's the common 6 security risks faced by most applications. So, spoofing, tampering, repudiation, information disclosure, denial of service, escalation of privilege. These are the things that are our path as an attacker to getting the good stuff. This is what I am doing when I am attacking an application to try and get to your data or to other systems you control. And don't forget, I might be doing these against you. I might be doing it against your user base. I might be doing it against one person to get to another. It's not all as simple as we like to make out. So let's start with prevention. How on earth do we stop getting attacked in a microservice space? Because hopefully we get all of that bit perfect, we never get attacked, and then we never have to worry. How many of you sat there going, I've never been attacked, so it's awesome, I must be doing it right already? Anyone? There's normally one person, even if in your secret self you're like, yeah, I've got this. Prevention is actually a big area, and we spend almost all our resources on it. But it's what we call an asymmetric problem. For every developer out there are 10 attackers doing vulnerability research or looking for some way to forward their objectives and motivations. So when we're trying to prevent them, we don't have as much resource or time as our attackers do. So it's a flawed problem. We can never actually get it to the point where we could fend them all off. So let's start with some basics first. Oh my God, the internet is a terrible place. How many of you have ever written some code and got stuck partway through and gone onto Stack Overflow for a solution? Anyone not raising their hand is a liar. Okay, I'm not saying you can't do this, not by any stretch of the imagination. We all do this. In fact, places like Stack Overflow have become a good source of crowdsourced information. However, not always true. This little gem came from Stack Overflow this morning, recommending that our lovely question, the original question producer, should just use MD5 to store his passwords. Great, because anything else is just being paranoid. Now, how many of you have a graphics card in your computer? Yes, all of you do. Most of you, I hope. There's a reason we don't like MD5 anymore, and it's because that little graphics card in most home computers is now fast enough to crack passwords using MD5 that even when they're salted, this is not a control. But the internet said so. So somebody somewhere is still building a system like this. I walked into a client 2 weeks ago, and they said, it's okay, we've started using bcrypt. And I went, yes. But we found that was quite hard. So next to it, we've put the plain text, just in case customer support need it. Okay, yeah, this is the kind of crap that we have on the internet calling itself security advice. I'm not here to give you the magic tricks of here's an OWASP top 10 and here's how to pop up a JavaScript alert box. I don't do that kind of talk. There are hundreds of talks out there that are just like that. What I'm here to do is kind of show you some of the real pitfalls that I'm seeing day to day and how we're addressing them. So, firstly, raise your hand, be honest if you don't know what OWASP is. All right, hi, welcome. This is the most important lesson you will take from today. OWASP is the Open Web Application Security Project. It is free. It is a global community of security people who are working to give free resources to the community, tools, guidebooks, cheat sheets, all about security. It's awesome. You should be getting involved. There is a link on this slide. The slides will be shared afterwards, but just go and dig in. Now, it comes with a caveat. Their website does look like it escaped from 1998. That's not my fault. I'm sorry. But the advice is still very good. So that's the last of our places to go for information. So Stack Overflow can be good, but use some common sense. Check authoritative sources first. Now, this is my personal crusade. So what does auth stand for? Can we all be clear for a second? We have two auth words in our life. We have authentication and authorization, and they are not the same thing. Now, when we are dealing with microservices, it becomes really important to get this straight, because the components that are doing your authentication may not be the same components that are doing your authorization. Your authorization might be happening differently in different places of your application. Whenever I see a specification that says, do auth stuff, I get a little bit concerned, because often we generalize and we put them into the same bucket. So my first thing I ask you, your homework, anytime you go and see a requirement spec and it says do auth, please just push it back with your red pen. You just go big cross through it, say try again, try harder. Because this is the root of our problem in security. We use buzzwords, we use abbreviations, and we don't really consider them. Now, in microservices, we have the luxury of breaking down our components and actually doing this in individual places. Now, we're going to come back to orchestration layers afterwards because they're fairly significant in this space, but you don't have to have one. You can just create your little services to either be atomic, just going to work on their own, or you could just have one of your little services that does authentication, another one that does authorization. You've got ultimate flexibility. That's part of the beauty of this, part of why it can scale and part of why you can send it over multiple teams. But at the same time, it means you don't have an even surface when it comes to your authentication and your authorization. Now, if we look at authentication first, we might identify central components like the little white square on this one and say, we'll have two-factor on this one. It's definitely important. It's in the middle. But what we don't factor in is that there's implicit trust between our microservices, that while our users might authenticate and authorize at border points where they interact, there are little trust mechanisms going on inside the app that mean you can go from a low-trust application to a high-trust application without really noticing you've done it. Oh, I'm losing microphones. Good. Awesome. The thing with authentication is it has to be consistent and it has to be planned. Now, this might seem like common sense, but a lot of the time I'm seeing microservice architectures spring up in places that have a large legacy code base. How many of you are working with a legacy code base? How many of you still got .NET, God knows what version, old in your life? Yeah, Java 1.4. Oh, yeah, I'm sorry. Yeah, this is the world we live in. Our services are not all written in latest Node with React UIs and with Scala over here and Rust over there. That's not how this works for most of us. So you end up with components that are limited by the technologies that they're actually written in. Old versions of Java and .NET do not have the same features as new versions of some of the later languages. So we have to have a consistent, planned approach, and we have to be able to test it. Authorization. Now, authorization is your next step, right? Your authentication is you are who you say you are. Great, wonderful, I'm going to let you in the door. But am I going to let you do anything? Well, probably not by default, hopefully. Think of this like your sliding doors going into the lobby of somewhere. Sliding doors have a tendency to fail open. If they break, they're going to let you in and out, because if there was a fire or something, they're going to let you leave the building and not have a horrible ending. In security, we actually want to go the other way. You do not want to be your sliding doors. You want to be a prison. If things are going wrong, if you have not made a decision, it should be closed. So many frameworks give you this, you can use decorators for your services, or you can use something in your general configuration. Have your base one, the one it's going to fall through to, be, nope, get out, nothing for you here. Because failing open is really dangerous for us. We don't want our public-facing APIs failing open. And this has to be applied to every object every method, every endpoint in your architecture. Now, that's fine when you're doing like Go 101 microservices and you've got 3 microservices and you're feeling really spectacularly good in the world. I've got customers who've got 300 plus microservices. That's not easy to do on that kind of scale. It also gets challenging when we start looking at the mechanisms we're using for our authentication or authorization, the tokenization. So there's a lot of different schemas you can use for your tokens. You can homebrew. Absolutely. Anything you can write, you can definitely write it and do a token system with it. I probably wouldn't, but you can. The problems we're seeing commonly, oh goodness me, I do apologize, 1 second. I'm going to end up holding this at this rate. Okay, so the problems we commonly see in the authentication authorization space is that the tokens are not being well managed. They're not high quality. That they survive much, much longer than they should. So this is not a new problem, this is an old problem. We've had this for sessions for a very long time, but now we've got different tokens. So the only thing that we're passing back and forth is this very large token. Now, things you need to consider, where they're being stored. Where are your tokens typically being stored in your applications now? Well, it depends what your UI is doing, right? Could be nowhere. Could be you're just writing curl requests or using Postman and it's just getting copied and pasted in. But it could also be that you are storing them in local storage or somewhere on a mobile device. And remember, a lot of these storage places are not secure by default. These are not encrypted stores. If you've got Chrome on your laptop, you can interfere with your local storage and mess around with those tokens. If you can do it as an engineer, you have to assume that your users can do that too, and your attackers. So you need to be handling that token very carefully and aggressively monitoring for strange behavior or strange usage of that token. Because if that usage pattern changes, you need to go, nope, I don't trust you right now. We're going to need to re-authenticate. We need to check that again. We need to do input validation. Now, it's been a long, long time since I've been in this field, and the one lesson we keep saying again and again and again and again and again and again is please validate your input. And yet, the OWASP top 10 has remained largely unchanged for about 10 years because input validation sucks. We are not good at it at all. Now, many of your frameworks do really good stuff in the standard setup. So .NET does some amazing stuff. C# does some amazing stuff. Django, which I spend a lot of time in, has some really good defaults out of the box. But the second you start writing custom APIs or things that don't use the big, bulky, generic framework stuff, and you just try and write something lightweight on the side, you forgo some of this. The other thing that happens is we expect all of our languages to do this for us. So if you've come from, say, a C# background and you move to something like Node, for example, you often assume that if it's using the same word, it means the same thing. But it really isn't. And I'm going to come back to that when we talk about the languages we're using and how they're affecting our security. Validation has to happen on every header, every request, on every method. That sounds really common sense. But if you couple this with the fact we very rarely put the right content type on our returns, that validation is stopping us returning scripts and things to our UIs, which don't know any better. They're just going to render things on screen. So, service composition. You've got a monolith. Great. Awesome. Fantastic. It means you're in business, and that's great. You're going to break it down into small pieces, and you're going to ship it onto the internet as microservices, and the world will be a great place. Awesome. Regardless of how many books you read and how many videos and how many tutorials you watch, this actually isn't that easy first time round, especially if you're dealing with a complex existing application. We tend to split it, we'll code our small service, start deploying them out, and then we move on to the next one, and it's very hard to come back to the old ones to have a look at them. Now, that has an interesting effect when we start looking at the security of our applications. So this is a crude example, again, seen in the wild. Obviously, no code, don't get confused. It's the same lesson, just without the code there. So we have 3 microservices, 2 of them using JWT tokens for their authentication stuff. Great, simple, good libraries and frameworks. Last one, what's that? Base64. If you are not familiar, or it's been a while since you looked at the difference between encoding, hashing, and encrypting, That's not particularly secure. And also, if you were to decode it, it's probably not a high-quality token either. So remember, the way to the heart of an application as an attacker is through its weakest part. So normally the oldest service you've written, the one you wrote when you were still watching the tutorials from Adrian Cockcroft or something on the internet. So go back and look at those old bits of code. I know that I have gremlins in my old bits of code. I'm probably sure you do too. We all know that microservices are supposed to be small and simple. That's quite straightforward. Awesome. How many of you have come across a monster microservice? A microservice that is pretending very, very hard that it's a cool kid and it really wants to come to the party. But actually, you took a monolithic developer and you said, make it an API, and lo and behold, they did. But it's giant. It's 500 plus lines of massively complex, highly coupled code that probably does 3 or 4 different functions when it should be doing 1. Yep. This is microservices. I'm not here to tell you the glorious future of microservices. I'm here to show you the skeletons that I see every day. And that's okay. Don't worry. If you see that kind of stuff, it means you're in a normal organization. You haven't quite got there yet. That's all good. But call it out. We all know the rule. If you're doing a code review, if you're given 10,000 lines of code to review, you will spot how many bugs? 10,000 lines? 0. You'll say, it's fine, ship it. If I give you 6 lines, you'll find 10 bugs. So treat your microservices in the same way. If you've got thousands of lines of code, it's not a microservice. It's okay. Do it in a blameless, nice kind of way. But just, say, come back again, try again. Remember that while we're breaking down our services, there is going to naturally be some coupling between them. It's highly unusual for you to be able to make microservices that can work entirely atomically, all on their own. Now, that's interesting when you start breaking out some that do heavier lifting than others. So, for example, batch processing, or dealing with any kind of large data transformation, or, say, your authentication system. Because if you don't consider this coupling, you end up in denial of service territory. If I can't get my objective, so if I want to take money or have problems, oh, my microphone again, there we go, awesome. Oh, I'm going to get sellotape, this is fantastic. Yeah, saw it here first. All right, it'll come right off, he says. Awesome, fabulous. All right, so if we have got services that connect to each other and I can't get to my objective, so my objective is your intellectual property or children's data or whatever I'm trying to get to, then sometimes just causing a denial of service can be an effect in and of itself. I can destroy your reputation in the industry. I can interrupt a crucial transaction that's going on. So making sure that the coupling in your services means that if one fails, that the others don't go down with it. How many of you do any kind of load testing or kind of failure testing in that way? If you don't, it's a really fun way to do testing. If you think testing is boring, this is the one to get started in, because basically you're going to destroy your entire architecture, and it's all for good things. You can get KPIs and things for this. The other thing to know is it may not be your code that fails under pressure. Now, we've all decided that using the cloud is good, and we'll come back to that. I like the cloud. Don't worry about the cloud. But how many of us love AWS's documentation? Yeah, that'll be no one. Sometimes it's not our code that is going to cripple our microservices. It's whatever we've hosted it on and however we've configured it. Whether it is going to autoscale or not autoscale. Whether you've set a billing limit on it and you're going to hit that billing limit and actually lock out all of your accounts for all time, which is the Azure approach. We have managed to cause 3-week outages in systems by triggering inbuilt controls on platform as a service. Not because we intended to, obviously, but you don't want to live in an industry where 3 weeks outage is a thing that you could actually happen. That shouldn't be happening to you, right? How many of you think your boss is going to be happy if 3 weeks later your code is still not running? Yeah, nobody's going to be happy. So, we've started breaking down our services. We've decided we don't want to put authentication authorization in each of them. We're going to outsource all this to an orchestration layer. Fantastic. There are great ones out there and many available. I'm not here to shill for a vendor. I don't care which one you choose. Choose the one that has nice stickers as a starting point, I think. That's how it works, right? So, Great, you're going to have a really powerful component and lots of little tiny components. Awesome. How many of you feel slightly worried about this? You should. This is worrying. Because claims like this happen. This was taken from a vendor website this morning. They are promising not only to do your orchestration, but protect you from all of the OWASP top 10, and adaptive threats such as bad bots. I don't know what bad bots are, and I'm a security person. So if you can figure that one out, please do let me know. I'd be interested to know what that actually means. But there's a worry here. What we've done is we've said, oh, you know, the security thing, I don't really need to worry about that because my orchestration layer is going to do it for me. Yes. That is really dangerous. That creates an approach in our development teams of, not my problem, somebody else can deal with that bit. We just do our core, pure functionality. This is rubbish. At some point, you are going to change your orchestration layer, or your orchestration layer is going to let you down in some way, and you're going to be really, really in trouble at this point. If it looks like magic, it's probably bullshit. OK. Other things you should know. People like me, attackers, people who do what I do but don't look like me, we are incredibly lazy. Incredibly lazy. If it's a choice between doing some kind of Ocean's 11 kind of heist that's going to take 3 weeks of planning and like I need a wheels person and somebody who's really good at talking to humans, or I can just steal your laptop in the lobby, I'm going to steal your laptop. Now, same goes for orchestration layer attacks. If you've got 300 microservices, but I know your orchestration layer is the gateway to every single one of them, I'm not going after your microservices, I'm going after your orchestration layer. Now, for many of us, that's an area we don't even control. That might be a third-party service, a software as a service product. It could be something we have internally in our network, but for most of us, it's somebody else entirely. Now, these are the features I'm starting to see in orchestration layers that scare me. So, impersonation. Somebody in the support team for orchestration service number 3 can pretend to be me at any time and show up in the logs as me. Now, that's really scary. I want to be able to see if an admin or a super admin logs in, I want to see what they do specifically, and it shouldn't ever be disguised as me. We're seeing investigation mode or SSL interception. So SSL is a pain in the ass to configure at the best of times. If you haven't run your tools through something like SSL scan or use SSL labs to test what your SSL status is, then please go do that, because you'll start to get a feeling for how complex something like SSL is to configure and maintain day to day. I do not want some other vendor on the internet meddling with my SSL traffic. That kind of breaks the whole point of it being encrypted. Now, if you're putting any services into your networks that say, oh, it's all right, we man in the middle of the SSL traffic and then we rebuild it and we send it on its way, always ask yourself, well, who's looking at that point? Who actually can see that data? And you'll see why that's important in just a second. Password sins of the third-party provider. I am unlucky enough to have done so many SaaS reviews of security in the last few months that I can probably do them in my sleep. How many of you run or work for a SaaS product? 3 or 4 of you. Please, I'm asking you, please, just once, I'm going to ask you nicely, as ambassadors for your industry, please get better at passwords. Please start caring about things like two-factor authentication. Please start caring about having good password lengths. Do not have a max length on a password. It's not a good idea. So, how do we do this? We need to choose appropriate technologies. It's okay to say no to new hipster unicorn technologies because they're not ready yet. It's hard. You won't feel like a cool kid, but it's okay. Restrict access to these things. Your orchestration layer is the most powerful thing in your architecture at this point, so not everyone needs access to it. Monitor it aggressively and configure it well. If it doesn't come with any awesome, I will work with your monitoring system, here's a little of a tip for you. If it's got an API, query the API, just use whatever scripting language you like, and use AWS Lambda. Ship the logs to whatever monitoring system everything else goes into. You can be up and running in less than 40 minutes as long as you know your script works okay and Lambda honors your versioning, which doesn't always happen. But you're going to have actual monitoring that you can actually interact with in the same place as everything else goes. Don't assume anything. Don't assume just because their marketing website is super slick and has all the right buzzwords in it means anything. I don't give a rat's if you say you're PCI compliant, that you have socks written all over the website. I really don't. What I care about is that you care about my security, that you are going to take steps on your behalf, and they're going to roll out to all of your staff, not just one person in your team. And then I want you to test these people regularly. I want you to make sure that they're getting pen tested. If you are working on an application that's going onto the internet that isn't getting penetration tested, or being put in a bug bounty program, or having a responsible disclosure process, you're doing it wrong. Now, in this space, there is a weird misconception that security vendors know what they're doing when it comes to secure development. Now, I want to ask you all, as better engineers than anyone in my community will ever be, please challenge us on this. I want to show you just the last 2 weeks from one of our researchers in the community. This is Tavis. Tavis has a problem with security vendors. He has been systematically doing vulnerability research over every antivirus and security product he can find, and it is raining vulnerabilities. Now, this was last week. This is the week before that. It goes on and on and on. Now, we're talking about Symantec, Norton, Kaspersky. I'm going to get in trouble with someone because this is on the internet. But don't assume if it's a security product they know what they're doing. Challenge them, push back harder than you would on yourself, because they have a greater duty of care than you do. Also, if you have a Fitbit set of scales, you should probably patch it, which I think is hilarious that we live in a world where you're patching your scales, but please do that. Okay, so identity and access management. We've got our orchestration layer. It's going to help with that. We hopefully haven't decided to homebrew any of this. We're going to use some nice practices. So things we need to care about. Principle of least privilege. How many of you work for an application development firm or on an application that has a God mode or a super user or super admin mode? Most applications have it somewhere hidden in the back end. It's the backdoor route that you get in and you do raw database queries and edits. It's the one where it's all gone horribly, horribly wrong and there's still a way to get in. I know about these things. I've seen them. I've written them. Your sins are my sins. We are in this together. We have to get used to the idea it's okay to say no. That it's okay to say, actually, you only need this permission. And that's going to mean that your roles available might get more diverse. You might end up with more of them. And that's okay. You don't have to just have one role that can do all of the things. But to do this, you need to define your roles well. What are the people actually using your application for? Now, how many of you work with marketing teams and have analytics tools in your application? Yeah, hopefully lots of you, because that's how we know what our customers are actually using. Any code that we're not using with a customer is dead code and needs to be deleted, which hurts us because we've put our time and money and love into it. But still, delete the code. It's the best thing to do. Now, use those analytics tools. I'm going to be a security person that tells you to go use crazy marketing tools to figure out what people are using your application, because then you can do set theory, because maths is fun. And look at what roles exist. You know, what groupings actually are being used, what functionality means stuff to different users. I'm going to ask you categorically, please do not go, it's okay, we've got fine-grained permissions. Fine-grained permissions is the pathway to dragons. Nothing good comes from this. I work with a client, they have 987 different fine-grained permissions in their application, which means if you talk about the possible permutations that make up roles there, you're talking in the tens of thousands of permutations of roles in that application. You don't need this. I'm going to say it. Engineers, we're really good at this, but the users don't care. The user will be happy if you just make their life simple. So don't go down the road of fine-grained permissions. Always calculate how many permutations does that mean, because every permutation needs monitoring and love in its own way. And then audit the heck out of this. You really, really do need so much logging and monitoring your application. It's unbelievable. So I commonly see people using Sumo Logic and Raygun from the vendor hall, doing great stuff with their application logic. But they ignore the security stuff around the outside. Access logs, if you're integrating with something like Active Directory, all of these things need to be pulled together. How many of you have ever been near a web application firewall? Okay, a couple of you. Yeah, I'm sorry. Right. Sad reality is web application firewalls are normally the primary defense we have in our organizations against bad things happening. However, They are given to the security team, which is someone like me or someone who's a sysadmin, and they go, protect it. So we put it into monitor mode. You put it into monitor mode, and it observes things, and it goes, well, if I was in real mode, I'd be doing stuff right now, and here's what I'd be doing. Now, in a perfect world, we would then go and look at these logs, and we go, all right, yes, that one can go on, and that one doesn't, and that one's a false positive, and that one's OK. And we turn it on to full mode, and it'll be fine. 8 out of 10 of the companies I've worked with in the last 12 months who have web application firewalls are still in monitoring mode 12 months after deployment. They are generating in excess of 67,000 alerts a day that are never getting looked at and processed. Why is this happening? Well, because your security team don't know your code base. They don't know what's normal and what's not. They don't know what super awesome microservice number 3 is supposed to look like. They don't know what crazy parameters you've said are OK. To them, it looks like JSON being fired around here, there, and everywhere, hopefully, and not XML. Please, if you are in an environment that has outsourced all of its security monitoring to another team that knows nothing about your application, go and ask them and give them help. Go and pull those logs to where you can see it, because the engineers are much more likely to be able to use this than anyone else. Now, just to reiterate what I said about AWS, or Azure, or any other cloud platform as a service, these are awesome. The number of controls you're going to get in this space compared to running your own infrastructure is great. However, this is a complex space. This is not one to just dive headfirst into. Please consult a grown-up before trying to configure security groups and roles and test them in any of these things. It's really tricky to make sure you've understood all of the complexities of the different components that are coming together. There was an interesting article recently calling Amazon's offering more like having blocks that you can string together rather than tools. And I think that's a fair assessment. They are not things that you can just intuitively use on their own. You need to know about 13 different components that all string together in different ways, where their documentation is written in a different style, where you may not know all of the things that you need to configure in advance. So please, don't think the cloud is going to save you. Go in with the knowledge you're going to have to do some learning, or find someone who's already done that for you. Immutable architectures. How many of us are playing with the vagrants and Dockers and all of that kind of stuff in the world? Yeah, that's awesome. It's really, really great. And I'm going to tell you why. I'm going to tell you why it's great as a defender, and why it sucks as an attacker that you're doing that. Please keep doing it. So, first things first, we all probably live in some form of compliance environment, and that sucks. I really don't like compliance very much. It can be a waste of energy, and it distracts us, and it gives us a certificate, so we feel like we've done stuff. But that's how we stay in business, so we're going to accept that. Things you're going to like about this space is it's going to be auditable. There are nice open source tools out there that can show you where the security issues are with your configurations, especially for things like Docker, which are very fast evolving. Just in the last week, Docker released security review for its containers that are held up in the registry. So this is really, really good. There is a Docker audit tool that's been around a while. There are similar things for Ansible for Vagrant. But the most important bit, not the auditability, it's configuration creep that it's getting rid of. Because it turns out you're not the only one that's turning your server into a special snowflake. You might be doing it, but in reality, it's actually an attacker who's going to do the most interesting changes. And immutable architectures get rid of this for you. So I want to give you a bit of perspective as to what actually happens when we compromise your host. Because for most of us, this is just, fuzzy black cloud of doom. Contrary to popular belief, we don't just go in there, ransack it a bit, steal the data, and get out. Most of the time, that's actually number 3 or 4 on our list. First thing we do, make sure we can come back and play another day. Because everyone likes to be able to come back and get the stuff you forgot last time, or come back outside of working hours, or you might want to use that host for other things like mining bitcoins, or setting it up to pivot into another network. So attacking someone from someone you've already attacked is super useful. You're going to install tools there. So it's very rare that all of the tools I need in a job are installed already on the box. If you have PowerShell, I can pretty much do a lot. But Linux hosts, hopefully, if they're configured well, don't have a lot installed on them. So I might need to put SSH on. I might need to put Nmap on, all sorts of fun things. Nothing particularly exciting. They're not, crazy Magic Wand tools, but I want to see them. Next thing, I'm probably going to clean up anyone else who's been there before me. Now, as an attacker, we're kind of parasitic. we need the host to be healthy to continue. So if we get into a box and we find someone was already there, then we might actually patch the vulnerability that they got in via and kick them out. Because I don't like sharing. Sharing isn't that much fun. So we'll clean up, we might patch, we might change a bit of configuration, lock someone else out, and then we're happy going about our business, finding data. And next thing, last thing, we're going to try and pivot. So we're going to try and go from this host, which might be interesting, to this one over here, which might be even more interesting. So in your microservices, this means going from one to another to see if I can find different data sets, accesses to different systems. Now, it's really, really hard to persist access and to keep all of these nice snowflake changes going as an attacker if you're using something like Lambda, or if you're using immutable architectures that are destroyed every 24 hours because you've done a tweak or a change. So don't just see them as a cool thing that you could be using because it'll save you time. There's actually a massive security benefit to this. There is nothing more irritating than trying to attack an organization that's infrastructure does not exist unless you're sending a query to it. It's a beautiful thing. Please, I want you to infuriate all of the penetration testers that ever come near your architecture and make it non-persistent. All right, that's a fancy word for saying, we've been doing some silly things with languages. So one of the beauties of microservices is that we can use any language we like. That's great, awesome, fabulous. But we're like kids in candy shops right now. It means people are going nuts, going, well, I've got some Node over here, and then I watched this talk about Go, and, well, we've got a bit of Java over there because, rocking the old school, and we decided to fork RabbitMQ, so there's an Erlang stack somewhere over here, and before you know it, bad things start to happen. Bad things are starting to happen because we're not always using the right tools for the right jobs. Not all of these tools are as mature as each other, and not all of them are designed for certain purposes. So if you find yourself using a language just because you watched a cool talk about it, or because you saw a really whizzy demo, always ask, is it the right one? There was a really interesting article from John Allspore at Etsy and talking about how they hire engineers. And he was talking about, actually, they don't want to bring more tools into their architecture. A good engineer can take a small subset of pre-vetted tools and do amazing things with it. Now, from a security perspective, this is even more important. Because not all of our technologies are equal when it comes to what they're providing you. Now, how many of you do Node? Any Node developers in? No? Well, that's really good, actually. Please, yay. Awesome. I'm sorry, Node people. But I'm talking about LeftPad. I'm talking about the things we've learned in the last few months about interdependency inside our package management systems. LeftPad was taken out. The developer said, nope, no more. What happened? We expected it to just silently go into the night and it would be fine. What happened was most of Node failed. It's because Node NPM is a highly connected, highly dependent package system. Most of the packages are less than 20 lines of code in length. And what we've got is a cascading failure situation where you can put code in or take code out and it breaks everything around it. This is not the same for all of the languages. So when we have so much variety in our language space, we're opening ourselves to risk from the package management systems themselves. Other interesting things about Node, you don't actually need to do any validation or have your code checked to have it in NPM. You sign up, you create an account, you push, gone, done. Now, if you're someone like me, what we see is the ability to then push malicious code in and have it adopted by many, many, many other dependencies and get into this highly connected mesh of packages. Now, this is basically the same way that worms work. So I could put malicious code in, have it 3 things become dependent on it. Each of those have 10 things that are dependent on those. And before you know it, I'm touching every piece of the NPM infrastructure or ecosystem. That's scary. How many of you have a good process for vetting your packages you're pulling from these places? I'm not seeing anything in the wild yet that actually you could use this and vet whether these packages are safe or not safe. We're seeing CVE checkers and things, but we're not seeing anything that goes, all right, do I actually need this? Is this good code? Is this sensible engineering? Now, to end this little section on some horrifically trite analogies, think of it like puppies. Every language and every package you bring into your system is like a puppy. It's cute. You get to play with it and do awesome, cool things you've not done before, and that's awesome. And it's going to poop occasionally, and that's okay, because it's a puppy, and you just scoop it up and you deal with it. Great. Then you get 300 puppies. Now suddenly that poop problem seems like a lot bigger problem than it was previously. So please, before you start bringing in more puppies into your life, consider what you're going to do with the poop. Right, so I'll wrap up with detection. So prevention's not going to get you the whole way. Please log all the things. We've mentioned this previously. I'm going to spend this section hammering things I've already talked about because it's the most important. It takes up to 18 months to spot you've been compromised, and in that time, all sorts of fun things will have happened. If you've only got 14 minutes of visibility in your logging, you're in for bad times when it comes to investigating what went wrong. You have to store your logs somewhere that's immutable itself, that's secure. Seems like common sense, right? But what we see most of the time is it's stored on host, it's fine. Now, do you remember that thing where I told you what I'm going to do when I compromise your host? Part of the cleanup is I'm going to flush myself from your logs. Your logs are going to be crisper and cleaner than they've ever been in their life. Your logs and poorly managed logs are actually a really good way to denial of service things. If you're sending them all to a poorly configured endpoint, that's a really good way to take you down, is if you take away that endpoint. So, yeah, please be careful. Another bit of homework. How many of you have heard of Hacking Team? Okay, Hacking Team was a prolific group of vulnerability researchers out of Italy. And there was a report put on the internet very recently from the guy who compromised them and aired all of their dirty laundry online. And he compromised them, and this is a very security-focused company, by attacking their centralized middleware. So their logging systems, their backup systems, their systems health checked. Anyone still using Nagios, this is where we're going to come after. So please bear in mind when you've got this very fragmented infrastructure like this architecture, that we're going to look for anything that's shared between all of your components. And we're not afraid to go after things like Nagios. Most of these systems have really, really elevated privileges too. And then watch your logs. How many of you filter the alerts that come into your inbox into a folder and eventually get to them? How many of you don't even get the alerts because you unsubscribed? How many of you have the Slack channel of doom where your logging goes to and one person goes in occasionally, but most of the time it's just noise and then occasional GIFs? Yep, we are crap at this. The biggest thing you can do is to not worry about which hipster language you want to do next. It's get this stuff working. Automate the heck out of your logging and get it monitored. Investigate things and go find out. You'll find more scaling of performance issues looking at the security logs than you're aware of at this point. I can find security flaws looking at slow query logs in MySQL. Your logs are super valuable, but we don't look at them, unless somebody tells us to look at them, or we've broken something. So, okay, it's a bit of a whistle-stop tour, I appreciate that. And when I say demos of things, everyone expects me to go, lol, I popped a shell for you. You're not going to learn that way, it's a magic show. But all of the examples I've given you are from real systems, from things in the wild, and written by real engineers, not unicorns who write books and present at things. So please, go into your world, do simple things, keep things simple and keep them reviewed, keep them logged. Because it's all very well moving from the big monolith that's costing us a lot and is painful to deal with to lovely, awesome microservices that we can be much more flexible with. But remember that as we break things into small pieces, the surface area increases. And surface area is all of the points in security that we can attack. If there are more points to attack, the more successful I'm going to be. So if you have any questions, please let me know. Obviously, there is an application that you're supposed to give me a feedback score in. I did not at any point tell you to try and give me the score of purple. So that never happened, just for the record. Thank you very much for your time.